4.8 can walk me through what they did, please and thank you. Gio, I appreciate you. 8 squared.
Or 8 equals x times 10, but then you square root.
Okay, take the square root of it. Okay.
And you to cancel out the square root, you square 8n. And then 8 equals 10x, or 64 equals 10x.
Yep.
And then divide by 10 with x. And then x equals 6.4.
I just realized we're using x here. Let's use a different variable. Let's use y. Because x is going to be this one. Let's say this was y, okay? All right.
And I did 10 minus 6.4, which is 3.6.
10 minus 6.4, which is 3.6. Okay, I agree.
And then I did x equals the square root of 3.6 times 6.4.
Very good.
And then I got x equals 23.04.
And you took the square root of it, and what'd you get?
3 minutes. 3.
You got 4.8. Guys, give it up for Gio. That was perfectly done. Grayson, what's up? Yeah. If you did x over, what was it? 6 equals 8 over 10 or something, that also would have worked, okay? If you set up a proportion. Remember, all 3 of the triangles in this diagram are similar to one another. So you can totally set up a proportion that way. Just remember, I personally don't like to do it that way. I like to use the geometric means, but every person's different, so feel free to use whatever method you would like. John. Yes, make sure you set a timer. Okay, guys, today is a pretty intense lesson. It's not particularly difficult. It's just something we have literally never seen before. So today we are going to learn about something called the tangent ratio, okay? And you're going to see a lot of today. It's going to be abbreviated as TAN, okay? Now, yeah, very good.
Oh, we're learning about the sin, cos, tan thing, aren't we?
Yep, sin, cos, tan, sine, cosine, and tangent. But we are starting very basic. We're only starting with one of them, which is the tangent ratio, okay? Now, listen carefully. Everyone on their calculator, you need to make sure that your calculator has a tangent button. It should say TAN on it. If you've been getting by with a rinky-dink calculator, that's fine, but you're going to need to get a new one that has a tangent button for this lesson. Okay? It must have a TAN button. Guys, it might be one of the small lettered buttons. Like, you know how they have, like, if you click shift and you click a button, it, like, changes whatever it's accessing? It may be one of those buttons, but you need to make sure that you have the tan button, okay? Now, I'm going to go through this lesson. I'm going to show you some of the stuff on my calculator, but you have to make sure that if you are having troubles getting the same answers, that you come see me after class, okay? The first thing that I want to make sure is that we're all in the degrees mode. So back to the notes. Guys, what is a trigonometric ratio? A trigonometric ratio is just a ratio of the side lengths, okay? In other words, what do you think about when you hear the word ratio, guys? One to one, 2 to 2, right? You can also think of a ratio, like what mathematically do we represent ratios as? Fractions, right? So we're definitely going to be dealing with fractions. So every time you see tangent of something, I want you to automatically be like, okay, fraction, okay? And it's a fraction or ratio of the lengths of 2 sides of what kind of triangle? A right triangle. You cannot, like, for the start of this lesson, when we're talking about sine, cosine, and tangent, we're going to be involving right triangles, okay? When you involve triangles that are not right triangles, the sine, cosine, and tangent get much more complicated. So for our sake in the beginning, we're going to assume everything is a right triangle, okay? And these are used, you can use the tangent ratio to find the measures of a side or an acute angle in a right triangle. So we're now going to be given less information, and we're going to be shown how to use the tangent to find more information about a right triangle, okay? So before, we were really getting by just using what theorem? The Pythagorean theorem. Do you guys remember that? But now we're going to be given an angle and a side, but only one side, and we're going to be able to come up with the rest of the lengths and the angles inside that triangle. Okay? All right. So what is the tangent ratio? The tangent ratio in a triangle that has to be a right triangle is defined as the following. You can take the tangent of either of your two acute angles. You do not take the tangent of which angle? The right angle, okay? The 90. You do not take the tangent of the 90. You can take the tangent of an angle, and it will be the length of the leg opposite that angle over the length of the leg adjacent to that angle. What side do you not use for tangent? Hypotenuse. Put a hypotenuse and cross it out, okay? You will not use the tangent or the hypotenuse in the tangent ratio. Are we clear? Scott. We are going to learn about SOHCAHTOA. I love that you've heard that before, okay? So, tangent. What is it, right? So the tangent, right, when you access the tangent, you always say that the tangent is of an angle. So the tangent of the angle A. Where's angle A on this triangle?
Right there.
Right here. Do you guys agree? So the tangent of this angle is going to be the ratio of the leg that's opposite this angle. Which leg is opposite angle A? Little a, right? Or BC. Do you guys see that? So we're taking little a and we're putting it over the leg that's next to angle A. What leg is next to angle A?
B.
B. So our ratio becomes A over B.
Wait, why wouldn't it be C?
Now, why wouldn't it be C? Well, C, I agree, is adjacent to angle A. But what did I say we are never going to use for tangent? The hypotenuse, okay? And C just so happens to be the hypotenuse. So we're going to ignore it, okay? We're going to ignore it for the tangent ratio. Now, by the same logic, let's go ahead and look. What's the tangent of angle B?
B. Over A.
It would be little b over A. That's it. It's the reciprocal of the tangent of A. Very good. So remember, look at angle B and go opposite angle B. What side is there? Little b. Do you guys see that? Opposite angle B. Do you see how little b is right there? That's always going to be your numerator. And then your denominator will be the leg that's adjacent to angle B. So the leg that's next to angle B would be angle A. Or, excuse me, side little a. Sienna. Very good. We do not take the tangent of angle C because angle C is how many degrees? 90. You never take the tangent of your 90. Okay? Go ahead, Gio. Make sure you set a timer. Any other questions, guys, before I move on? All right. So let's try an example. I want you to express the tangent of angle R and angle S as a ratio. Let's start with the tangent of angle R. What would it be as a ratio? Remember, ratio means what? Fraction. So let's write it as a fraction. Nick, what do you think it is? It is going to be 3 over 8. How did you get that, Nick? Well, I agree. The 3 is the side that's opposite the angle R, right? But then why is 8 the denominator? Christian? Very good. It's adjacent to R and it's not the hypotenuse. It's another leg. Okay? By that same logic, guys, who can tell me what the tangent of angle S would be? Cody? 8 over 3 is correct. Okay? Opposite angle S would be the side that's 8, and then the adjacent leg is 3. So we put 8 over 3. Got it? Could I ask you to find the tangent of angle T? No. Cross it out, okay? I will not ask you to find the tangent of the 90, because you can't do it. It'll only ask you to find the tangent of an acute angle. Actually, let's use our calculators now to find the tangents of certain angles, okay? So I want you in your calculator to plug in the tangent of 45 degrees. You put tan, I'll actually do this one with you guys. Now, we all got tangent of 45 equals 1. That is our answer. If you were given a calculator, that's perfect. But I want to show you why the tangent of 45 is 1. Remember, if we're talking about tangent, I told you what kind of triangles are we dealing with? Right triangle. So I want you to draw a right triangle. Right triangles have one angle that is always 90 degrees. And we were finding the tangent of what angle? 45, right? So let's make one of these angles 45 degrees. What would the other angle have to be? 45. Do you guys remember the special right triangle 45, 45, 90? Yep. Okay. What were the legs? A's, right? They were A and they were A. And then the hypotenuse was how much? A times the square root of 2. So now guys, focus on one of your 45-degree angles. Let's say the top one. Let's focus on this guy. What would be the tangent ratio of this 45 degrees? The tangent of this 45 degrees. It would be A over A, right? What is A divided by A? No? Isn't it 1?
Yeah.
Wait, what did we say the tangent of 45 was? Say what? Cool or not? A little bit? No? You guys are being boring today. Okay, now the tangent of 36 degrees, I can't there's no way for me to show you that because it's not one of our special right triangles. This one you would be forced to use a calculator. So take out your calculator and type in tangent of 36 and you would get 0.72654. 0.72654. Guys, 99 times out of 100, I'm going to ask you to round to what? The 10th, right? So round to the nearest 10th, you would get 0.7. What? Yeah, but if it may ask you for a fraction, right? But Zach, it didn't give you a triangle, so you don't even know what any of your sides would be for the tangent of 36. Do you see the difference? If it gave you a triangle, you could find the angle that's 36, go across, put that number over the leg that's adjacent. Okay, now for C. In letter C, we're being asked, okay, use tangent of some unknown angle. We'll label it angle A. And it's going to equal 2.4751. Now, I need you guys to write this down because this is very important, okay? I want you to write down the exact same thing over here on the right, though, so we have a little bit of space. We were writing the tangent. What did I call the angle? A. And it was 2.4751. There's a function for trig, okay, trigonometric functions, that's the inverse tangent. It's tangent -1. So it's written like this, tangent -1. And what you can do is you can take the tan inverse or the tanverse of both sides of your equation. Now, the reason this is so helpful is guess what happens when you take the tan inverse of a tangent? They cancel out. So now on the left side of my equation, what do I have that's left over? Just A. Because tan inverse is the inverse of tangent, so it cancels it out. It's like 1 over tangent. So A equals, and now we have the tan inverse, or tan -1, of 2.4751. Now, your calculator should have a tan inverse button. It's tangent with a -1 right above the N. I want you to find that button, and I would like you to plug it in for 2.4751 and see what you get. Okay, I got that angle A was 68.0001,057. That would be 68.0. So the angle angle A equals 68.0 degrees. Remember, when you use the tan inverse, you're basically using the inverse of tangent, so your answer is going to be an angle, and angles are always measured in degrees. Okay? Say that again? Yes, you should always put 0.0 if it asks you to round to the nearest 10. Okay? Yes. So you may have to use the shift button to access the tan -1. Because the shift button will access anything that's written above any of the buttons. Okay? Good questions. All right, now for this one, for letter D, let's say we wanted to make it angle B. How would I find angle B? What would I plug into my calculator? I would use the tangent inverse of what? 0.8098. Very good. So try it. Plug in the tan inverse of 0.8098. I got 39.00055. So we'll round that to 39.0 degrees. I did both of them actually. Wait, what was your question, John? You could have made it whatever letter you wanted. It just wants to know what value goes in that blank, right? Yes. Yeah, sure. Mm-hmm. Any other questions, guys? This is very new. You probably have not seen this before, have you? Okay. All right, so next problem that I want to do is is this your next slide? Or is this where it got jumbled? Which one did I skip? This one? Okay, let's go back to it. So this one should be fairly easy. What's the tangent of A going to be?
2. Oh wait, 2 over 7.
2 over 7, very good. What's the tangent of B going to be? 7 over 2, very good. Now, how do we find the measure of angle A? The inverse tangent of what? 2 over 7, very good. You got 15? 15.9. I believe that's correct. What units do we give this guy? It's an angle, so it must have degrees. Very good. What about angle B? Yeah, you could take 15.9, take that away from 90. Let's do it using the tanverse again so we get proficient. Take the tanverse in your calculator of 7 over 2. Did you get 74.1? 74.1?
Wait, why are you doing 7 over? Oh.
Did you get 74.1 degrees? You got 40? Did you take the tan inverse of 7 over 2? Oh, make sure that you put them in parentheses.
On parentheses?
Yeah, the 7 divided by 2 should be in parentheses. Otherwise, what you're doing is you're taking the tan inverse of 7 and then dividing it by 2. There you go. You got 74.1? Okay. This is what you guys have next? Okay. So, we'll go to this one and then I'll go back. I want you to use a calculator to find the tangent, okay? So, right now, we're given one side of the triangle and 2 of the angle. Actually, all 3 of the angles. Do you guys agree? Normally, we would be given 2 sides and we'd be asked to use the Pythagorean theorem, correct? Do you guys agree we can't use the Pythagorean theorem here? Because how many sides am I missing? 2. we're forced to use tangent. Now, the cool part is you can use the tangent of either of the two angles. But I can't take the tangent of what angle? The 90. So pick one. Which one do you want to use? The 35? Okay, so let's pick the 35, circle it. We're going to say, okay, the tangent of 35 degrees should be equal to what? What ratio can we set up in this triangle that involves tangent? 10 over x. How'd you get that, Christian?
The angle, the side opposite the angle, and the adjacent that is not.
Very good. The side opposite the angle, which was 35, so we put 10 over the x value, okay? Because that's the adjacent leg. Could you solve this for x? Could you solve this for x?
Divide 10, tan, 35. I mean, when you multiply 10.
What would you do? Multiply?
You solve the tangent of 35?
Okay, what is the tangent of 35 degrees?
0.7.
It's rounded to 0.7?
Yes.
Okay. What would you do now?
I guess
Multiply by 10 on both sides? So if I multiply by 10 on both sides, right? 10 times 0.7 becomes 7. But remember, you have to multiply the 10 and the 10 because those are both numerators. So it'd be 100 over x. Oh, no. Those don't cancel out. Don't do that. Okay, so let's not do that. Divide by x over 10? What if we backtrack, right? What if we thought this left-hand side was a fraction? And we put it over 1. What could you do now? Cross multiply. Very good, Hannah. So let's cross multiply. Cross multiply, take tangent of 35 and multiply it by what? X. So we're going to write x times the tangent of 35 degrees equals, what's the other cross multiplication? 10 times 1, which is just 10. Now this is much easier. How could I solve for x now? Set a timer. How do I solve for x?
divide the tangent by both.
Yeah, divide by the tangent of 35. Because what are x and the tangent doing? What operations between them? Multiply. And how do you undo multiplication?
Division.
You divide. So we're going to divide by the tangent of 35 degrees to both sides. Boom, cancels, boom, cancels. So we just have what on the left-hand side? X equals.
10 over the tangent. We don't solve for the tangent?
You do now. Now you're going to take out your calculator and you're going to type 10 divided by the tangent of 35 degrees. But the reason I did it this way, guys, is because I didn't round anything, okay? I'm going to get the exact answer, okay? You don't want to round until the very end. So let's go ahead and do 10 divided by the tangent of 35, close your parentheses. I got 14.3.
Yeah.
Now, just so we're all on the same page, let's do the exact same thing, but let's use the other angle. We should get the same answer if we do it correctly. So I want you guys to take the tangent. What was the other angle? Of 55 degrees. So what ratio would the tangent of 55 degrees make? It would be x over 10. Very good. Now, this one's a little bit easier to solve. How could I solve for x? What would I need to do? What's going on? Like, what operation is going on with the x right now? Division, right? It's being divided. How do you undo division? So what could we multiply by to isolate x? Just multiply by 10 to both sides. What happens when you multiply by 10 to both sides? The tans are going to cancel out, right? So, and now you just have to plug into your calculator 10 times the tangent of 55 degrees. And let me know what you get.
14.
You don't say. It's 14.3 regardless of what you did.
So what you're saying right now is that you just to find the answer, if you do the angle that's right above the.
It might be, okay? You can do it both ways, Nick. Whichever one you would like, okay? You can use that method. So Nick says, did you guys hear what Nick said? He said it makes sense to use the angle that's opposite your unknown side so that you get an easier problem like the one in red to solve. Because that was easy, just multiply by 10 to both sides. Do you guys agree? So if you do that, that's fine, okay? Just remember that that method involves using the side that's opposite as your x. Yeah, Diana.
14 instead of 14.3.
You got 14 instead of 14.3. Did you round?
Yeah, that's my,
You rounded before? You did 10 times the tangent of 55?
yeah, 10 times the tangent.
Okay. Any personal calculator questions, guys? I will answer them just at the end, okay? Yes. Go ahead. Set a timer, please. All right. Complete the triangle. So, when it says complete the triangle, guys, we have to find all angles and all sides.
Oh, I see. I rounded it.
You found it? Okay.
Yeah, now I know why. Yeah, I got it.
Okay. All angles and all sides. Do we know any of the angles? No. We know one of them. Which one? We know that this one is 90 degrees. Very good. We know two of the sides, but we don't know one of them. Do you guys agree? If you know two sides in a right triangle, how could you figure out the third one? What? Make it x. Okay, sure. How could we solve for x here? Pythagorean theorem. Very good. So, what do I set up to solve for x? Using the Pythagorean theorem? X squared plus 8 squared?
Equals 17.
17 squared. Very good. Both of the legs squared and added together should add up to the hypotenuse squared. You guys with me? Okay, what's 8 squared?
64.
What's 17 squared?
Oh,
289.
289.
289.
What do I do next?
Subtract 64 from both sides.
Subtract 64 from both sides. What do you get?
225.
X squared equals 225.
15.
Very good. Take the square root of both sides. You get x equals
15.
15. So x is equal to 15. What's he at?
30.
Seconds?
Yeah.
Okay. What's that?
This side.
Did I miss that one? I'll go back. I'll go back, I promise. Okay. So now we have to figure out the angles, correct? So pick one. Which one do you want to start with? B? Okay, start with B. The tangent of B would be what? 15 over 8.
He knows he's
15 over 8. What did I say to do when we know the ratio, but we don't know the angle?
5 seconds 30.
How could we figure out this angle, B? Tanverse, very good. The tangent inverse. So we're going to say B is going to be the tangent inverse of 15 divided by 8. Plug it in, see what you get. So the tangent inverse, are you sure you're using the tanverse, the tangent inverse?
Wait, why'd you use the tanverse for this?
I think I got 61.9. So angle B is equal to 61.9 degrees. Now let's not overcomplicate things. How do you find A the easiest way possible? Add them and subtract it from what? 180, right? Or just subtract 61.9 from 90 because you already know one of the angles is 90. So let's do 90 minus 61.9. Use your calculator. I got 28.1. So that's my final angle. You are going to see problems like this. Guys, make sure you wrote down at the top when it says complete the triangle, you need to find all of the angles and all of the sides. I have all of my angles and all of my sides. Do you guys see that? That last side? Remember the last side you use the Pythagorean theorem, okay? How are we doing? Are we okay? I skipped a slide, didn't I? All right. We're almost there, guys. This is the last example I'm going to do with you guys. Find the value of x to the nearest 10th. Now before, when we were asked to find a side in a right triangle, we used what theorem? Pythagorean theorem. But here, can we use the Pythagorean theorem? No, why not? We don't have the hypotenuse, and we're also missing the leg, that's x. Do you guys agree? So what should we try instead now? What did we learn today? Tangent. What angle were we given? The 24. So take the tangent of 24 degrees, and what ratio should that be equivalent to? X over 20. Very good. And now I want you to solve for x, correct? How would you solve for x? Multiply both sides by 20. So now in your calculator, all you're doing is 20 times the tangent of 24 degrees, and that should give you x. You got 8.9?
Yeah.
I believe that's correct. Let me just verify that. Tangent of 24 times 20. Boom, 8.9. All right, that's it, peeps. Turn these in.